Hi, welcome to the breadboard. In some previous videos we've been looking at the Siemens Simatic IOT2020. It's an Arduino compatible development platform that has been put into an industrial format and made available for the maker, education and hobbyist market through RS components and through the Arduino.cc website. Now, one of the problems that have been raised by a few people is how do you add some I/O to the board, and also how do you keep those I/O devices covered when you have it into a final installation or something. Quite typical when you have things like an Arduino and you get a board maybe like this. This is a relay board. You just plug it on top of the Arduino, but it's all exposed. So here's a Arduino Uno, and when you take something like a shield, this is a relay shield. This is the shield that you can buy from Arduino, from RS components, etc. When you want to put them together, you basically put it on top and you connect the pins, and there you are. That's everything you need connecting. Now obviously with the relay inputs and outputs, the relay outputs here, you need to add wiring to go off to whatever load you're connecting. Bear in mind these are not mains capable, they're maybe 24 volts or something like that. And you've got a bunch of headers, and then you could even stack something else on top of that again. Now when you're prototyping on a desk with your laptop connected to it and you're just messing around, having it like this is all well and good. Now, one of the things that I've explained to you for the IOT2020 is that it's Arduino compatible. This is the unit we've been looking at. And if I just open up the covers on here a second, you can see inside we have an Arduino header just here, in here, right? And there's normally, when you're done, you have a cover over it like this. Clicked in properly, there we go. And this whole unit is CE and UL certified. But if you put a relay board in here, the first thing that you'll notice is that it's a little bit deep into the board for getting access to the connectors. And if you put a lid on top of this, right, you can't get to the connectors, you can't get to the headers or anything else. So what I wanted to show you today is two things. One is how to raise this up easily so that you can get at the connectors much easier. And the second one is how to make a lid, a replacement lid for this, so that you can lift it up and get access to the headers and everything else. So the first thing we'll deal with is how to get the relay board, in this case, raised up enough so it's sitting about like that, so it's above the connectors, so that you can get a hold of the screw terminals easily, even when it's plugged in, and be able to connect things up and disconnect them. So let's just get closer to the bench and I'll show you how we do that. So here's the IOT2020, just a bit better view. You can see the headers for the Arduino connectors. And what you need to do is we need to be able to bring this up a little bit. So one of the things that I have, and you can pick these up from RS Components and lots of other places, is this is just a prototyping shield where it's got the headers on for the Arduino R3 connectors, and it's got some sockets as well as the pins. So basically it extends the socket up. Now you can buy these connectors on their own, or in this case I just happen to have them on a prototyping board. You can get these for up in Canada, if you shop around, you can get them maybe $10. They're available from RS Components at a very good price, so just shop around or get them from RS Components. They're easy to install, and even if you don't use it as a prototyping board, it makes a great way to extend up the height of these internal connectors so that you can bring them up a level. So what you do is just plug this one in. We'll just do that now on camera. There, and just push it down. Now there's nothing on here, so everything is now just raised up, but it is not, there's no active components on here to cause any issues with the Arduino capable headers or the IOT2020. It's just completely passive. And if you look now, it's brought the connectors up quite significantly. You can see it's very close to the top now. So now if you take your shield, in this case the relay shield, you can just plug this right on top of this one, and now you've got some significant height improvements above the case, and you can see you can see here now that it sits just proud of the top of the case where the lid would be, and you've got full access easily to all of the connectors, the pins on both sides, etc. But what do you do from there? If you take the lid, you don't want to necessarily just leave this exposed. I mean, you can put this side cover back on, no problem. I just clip that back in. All right, that covers this piece up. And that's all well and good, but what about this side? All right, you've got all these holes and everything else. The existing lid now, it won't fit on. All right, now what I'm going to also show you is how to create a lid of your own and 3D print it, or have it 3D printed through a service. And I'm going to make one that is for this particular relay shield. What I'm going to do is I'm going to take the 3D model for this lid, for this specific lid, and I'm going to extend it so that it will actually sit over this. We'll have a look at it printing, at least the first cut of it, and then we'll probably have to make some tweaks, and we'll get a lid. Okay, done some design, and here is our first cut at printing a lid. Now I've printed this in ABS because that's what I happen to have plenty of filament of, and it was also already loaded up on the printer. So you can see there's a little bit of curling on the edges here. Now fortunately for me, this is actually only support material, so it curled up off the bottom, but the actual bit that's of more of interest is this bottom side here, where it clicks into the edge of this case. So you can see we've got all of the pieces that we had on here. I printed it in green, but that doesn't matter. And I've also, you know, now you've got clear cutouts for the shield headers, for the Tinker Kit connections. You've got access to the screw holes for the terminals, and on the ends, I haven't pushed them out yet because it's got support material in here. We have the holes for getting at the screw terminals. So let's just pull the material apart and strip it down and see what we end up with. So the problem when you print support material, of course, is you do get a little bit of a rough edge, but at the end of the day, it works just fine. You see, just pull it off. You can sometimes maybe use a pair of pliers or a screwdriver or something to help you as well, but that seems to be coming off reasonably well. Might need to take a file to it. If this was printed with PLA, it might come off a little bit easier. But nevertheless, it seems to be doing just fine. So we'll just pull this side off. Okay, some of the end support material. And that one came off quite easily. And there's some that goes through to make the hole here for the cables to go in. You get a knife or some modeling tools to clean this up, of course. So let's just pull that out. That pretty much is all of that. Let me just go get a modeling knife and just clean up some of the sharper edges on here, and then we'll see how it fits. Now I'm doing this with a camera in my way, so it's just a little bit harder for me, but you just trim with a little modeling knife or tool just to clean the extra pieces off. I'm just going to do a little bit of this because I don't want to waste your time watching me clean all this up. A little bit of sandpaper or something, or actually to get rid of a lot of this you could also use acetone, like ABS solvent, just to clean up the edges. But there we go. That's got most of it. There's a few little pieces here just to clean up, and that's pretty much it. So what we have now is our lid. Now I don't have, if you look at this lid, this is where it goes. You can see the difference that I have here now. So let me put that the other way. So this is the lid that was original, was the gray one, and there's the new one. So same sizes, width and things like that. I've just extended the height, cut the holes in. At the other end, you'll see that there's little tabs on here. I don't have them on this model yet. The lid model that I managed to get a hold of actually didn't include them, so I'll probably have to add them myself in the modeling. I wanted to just first of all try a fairly crude print just to see if it was going to fit well and how well I got my holes lined up. So let's get it against the IOT2020 and see how well it fits. So there we have it. For a first attempt, that is not too bad. It looks like on this side I've got all of the pins for the header nicely lined up. If I take this off, you can see I'm not missing out on this very last one. So that's lined up nicely. On the other side, I can probably shorten this a little bit because I didn't account for the fact that it's actually a shorter run on this side, so I could bring that in just to hide this piece. For the screw terminals, I've nicely got nice access to those. I could probably even shrink this hole a little bit if I wanted to. On the end, it's nice, easy access to push the wires in for it. On the other end, again, nice, easy access for the wires to go through. Here I do have a slight error in my alignment for the holes. I need to move this whole slot across a little bit. Now what that's also going to do is break this connection here, so therefore weaken this a little bit. I don't know if I'm going to be able to do anything to maintain that, which probably will be okay because this will be filled in here as well. It just might be a little bit weak there. I don't know if I can put something across a couple of these. I'll have to try putting some connectors in to see how well they fit. So that drops in there. It does need the tabs though to lock into here a little easier. And on this side, of course, you've got this. So if I take the standard lid and try and drop that in, it will fit in nicely, and there you go, all locked up. So I've got access to all the pins. Let's put this back in. So we have access to all the pins for the Arduino edges here and here. We have access to the Tinkerkit headers. We've got access to the relay connectors, and if all we do is add some tabs here, and I believe there's there's one tab here and one tab here as part of the 3D model, we will be set. And I'll just, of course, make this adjustment to bring it in. I'll see if there's a way I can fit these. Let me just see if I can find a couple of connectors for this and see how well they fit. So I have a couple of 4-pin header shrouds here. I'm just going to drop them in over the connection to see how well they fit. So that's that one clicked in. And I'll go to the end one, see if I've got enough room to actually click it in. Let's take that one back out first a second. Yeah, it looks like I need to shift this hole slightly this direction as well. I've got I think between this one and here, if I slide these two across a little bit, it's going to fit just nicely, because that won't quite go in, but this one fits in no problem, as would the next one. See, these fit in quite nicely. And if I take a standard 4-pin kind of flat header, they will also connect easily enough. These last ones are 3 pins for digital in, digital out, and analog, and things like that as well. But all the other connectors are fine, and then this one. So if these are shifted up a little, this is shifted a little bit this direction, and this is shifted, that'll be just perfect. So I'm going to have another go at the model, and I will add the tabs in to hold it on the lid a little better, and maybe I'll print it in PLA instead of ABS too, so that it will have a little bit less warpage. But from a fit perspective, that's pretty good. Anyway, I'll go away, do that. For you, it'll just be a matter of not even seconds. For me, it's going to be a few hours, because this took about 2.5 hours or so to print. And I'll share the models once I'm done. So for this second print, I decided to use some PLA. As you can see here, there are no curling whatsoever on the print. So what I've done, as you can see, is if I just turn this one around a little bit, adjusted the aperture here for the connectors, shrunk down the Arduino Shield connector just to perfectly match the Arduino Shield here. A little bit of adjustment on the position of these two access holes for the screw terminals, and so haven't cleaned this up yet, but as you can see, it has printed a lot nicer than this one. Even if I put them side by side, you can see that the print quality is much better on the PLA with my printer. Now the other thing I did was to add the tabs that I need here and here to go into the end of the enclosure, and also added the side tabs needed to clip into the case as well. These are ones that are on the original case that were not on the model that I had got, that I was using as the basis for the new lid. So time to clean up the support material and see what we have and try it back on the IOT2020. So I'll be right back as soon as I've pulled all the support material off. Okay, so here we have it all cleaned up, removed all the support material. There's a few little marks, just the nature of printing on top of support material, can't really be helped. But to print it the other way up, as in this way, would cause a huge amount of support material all on the inside, and I don't want to waste that much filament. So this is it. Now here's the original lid. Let's just zoom out a little bit, that it's based upon, and as you can see here, that was the original one, so I've heightened it. Still have these tabs like here and here. On the sides now, I put it the other way so we can match it up. We have the little tabs to lock it into the case visible. If we get them lined up there. And then on the end here we have the tabs that would lock it into the end of the case. If you can get those to see very well. That are now nicely lined up. So none of these were on the original green print. So I guess the next thing to try, and I also obviously adjusted these holes for access to the screw holes and things on the top of here. So now let's put this in and see how well it fits. So at the end of the case you've got the two holes here. That's what these tabs on this end are for. They're supposed to slot in the holes. Now if the printing is gone correctly, they should fit right in there, and they do, which is nice. And the other end, these little tabs here, lock into little slots that are on the sides of the case, so that it basically clicks down nice and tight. So let's see how well we line up with our connectors. So there we have it. You can see in there we've got direct access to all where the cables would go into the terminal blocks. Same for this end here. You got access to the terminal blocks. On the top now we got access easily to all of the screw terminals, and we can see where the cables are going out. Same for this end. Got access to all the screw terminals easily. And now we have better access to the jumper connections. I've shaped it better to fit around the profile and leave less exposed. And on this side we did have quite a gap up here where I'd made these two the same length, and now you can see the headers fit perfectly for that case. So there we have it. And of course the PLA printed without any warping on the surface, so we have a bit better finish too. So that's the end of that. The next step now with this relay board, and I'm going to do that in a separate video, is to show you how to use it with both an Arduino sketch initially, and also using Node-RED. See you on the next video. Bye.